Hello everyone, my name is Yacheng Tang and I'm from Evasion Digital in the US. Today, my topic is an intelligent question answering system based on Power Knowledge Graph. The motivation of this project from multiple aspects. The first is the explosive growth of data and the continuous accumulation of redundant information in Power system has dramatically increased the difficulty of obtaining valuable information accurately and quickly for users. The second is the Power Domain Knowledge Graph describes the complex relationships between data entities in a structured form and expresses the complex related information closer to the power engineer's cognitions. Based on the Power Knowledge Graph, an intelligent question answering system can help business users obtain the critical information from the massive power data efficiently and relies on association analysis and reasoning during the data query to provide multiple rounds of question and answering. About the framework of the proposed IQA system. First, it performs the in-depth analysis of the question sentence, which implements the graph ontology model and specific knowledge to identify entities in the question sentence. Then, carries out semantic analysis to extract the target and constraint conditions. Next, the system performs the knowledge reasoning, use the graph ontology model to search and merge the reasoning paths, automatically generate a query sentence, and then run the query in the knowledge database. Finally, the query result can be visualized and the answer is returned to the user. The four main steps in the in-depth analysis of questions are performed within the same time. Entity recognition can provide a comprehensive vocabulary to achieve accurate word segmentation based on the dependency tree, which is shown in the figure. The extraction results will be recognized as entities to the constructed ontology model. As shown in the figure, building an ontology model for the power system based on a graph database can fully use the natural consistency between the physical topology in the power grid and the nodes and edges data structure in the graph database. The constructed ontology model can form the power knowledge graph more intuitively through entity loading. The knowledge reasoning algorithm designed for IQA is a graph shortest path method that integrates multiple rules. It determines the shortest path between all constraints nodes and the target node. The shortest path satisfies the laws in all constraints, such as the selection of multiple edges between nodes and logical combination judgment, which include and, nor, all, and so on. The goals and the constraints corresponding to the question, as well as all the relevant knowledge in the database, can be displayed in the graph on the right. The last question is the extraction of the previous question. The current question's target node is still the manufacturer, and the constraints that include the oil leak tag and the transformer equipment type are kept. Another filter condition, voltage level as 220 kV is added from the new question. All the related constraints and the returned results are displayed on the right side. For the test results, all relative parameters are shown here. The IQA system works well in the experimental environment. The question answers are compared with our expert system. The average question resolution accuracy rate is close to 99%. The average answer accuracy rate is close to 98%, and the average response time is less than 200 ms. The main contribution of this paper is to develop an IQA system based on the power knowledge graph. In the future, we plan to discover some approaches to improve question parsing accuracy, such as offer users question templates and design a question return mechanism. Thank you very much for your attention. If you have any questions, please feel free to contact me.